Notice this is our second example and our equation is not in slope-intercept form, so we're going to graph it in standard form. The very first thing we want to look at is, do we need a solid or a dotted line? Notice we have 2x minus 3y is less than 12, so we just have a less than sign. So this time we want to use a dashed line. Then you need to graph your equation. So to graph in standard form, you need to find your x and your y-intercepts. So to find x, you need to plug in 0 for y, and then to find y, you need to plug in 0 for x. So I've done so. On the left, I have an x-intercept, and on the right, I'm solving for my y-intercept. Whenever I go down looking on the x-intercept, I have 2x minus 0 is less than 12. Then on the y-intercept, I have 0 minus 3y is less than 12. I have 2x is less than 12. And on the y-intercept, I have negative 3y is less than 12. Lastly, for the x-intercept, I have x is less than 6. And you can see on the y-intercept, I had to flip my sign because I divided by a negative, and I have y is greater than negative 4. So to plot these, you just need to plot a point. Notice I plotted a point at x equals 6. And then I have a point at y equals negative 4. And I have drawn my dashed line through these 2 points to plot my equation. Next, I need to pick a test point to decide where I'm going to shade. Since my line doesn't go through 0, 0, I'm going to pick 0, 0 as my test point. Remember, plug in a 0 for your x and a 0 for your y. I've done so, and after solving, I got 0 is less than 12, which is a true statement, so I need to shade where 0, 0 is contained, so I'm going to shade above my line. Now you have finished your graphing once you have included your shading, and this is complete.